Good morning. In the last two classes, we had seen how to derive an expression for depression of a beam. And today, we are going to see how we can determine the Young's modulus of the material of the beam using the method of bending of beams. This is how we are determining Young's modulus in our practical class. So here you can see a beam AB which is of rectangular cross section, and we are going to find out the Young's modulus of this beam. That means Young's modulus of the material of the beam. So the beam is supported horizontally and symmetrically on two knife edges, as you can see it in the picture. L, capital L, is the distance between the knife edges. So the knife edges supports the beam and the weight is hanged at the middle portion of the beam. And you can see a pin attached to that weight at the middle. So we can apply a series of weights and the corresponding depressions can be measured or noted. So this is the experimental setup in which a rectangular beam is supported with the help of two knife edges and weight is suspended at the middle. And in order to measure the depression occurred when we apply the weights, we are placing a small pin so that whenever the weight is hanged, the pin gets depressed, and we are measuring that depression of the pin with the help of a traveling microscope. And we can suspend a lot of weights and we can measure the depression of the pin using traveling microscope. And with these values, we can plot a graph so that mass which is suspended is taken along x-axis and the depression occurred for the pin or for the beam is denoted along y-axis. And you can see as we plot these values, we will get a straight line. So a straight line graph is obtained while plotting a mass along x-axis and depression along y-axis. Now what will be the slope of the graph? Slope is y by x, isn't it? So delta divided by m. We had found out the expression for delta, that is the depression of the beam which is supported at the ends and loaded at the middle in the last class. That delta is given by WL cube by 4 by BD cube, since this is a beam of rectangular cross section. So from that equation you can write the equation for y, because we are determining the Young's modulus of the material of the beam. So from that equation you can write y as WL cube divided by 4 delta BD cube. So rearranging this equation again, we can take GL cube by 4 BD cube as a single bracket, and we had determined what delta by m as the slope. So the m by delta is given as another bracket. So we have the value of delta by m from the graph and we can substitute it in this equation so that we can find out the Young's modulus of the material of the beam. See, L, we know the value of G, acceleration due to gravity, isn't it? Now, we are placing the knife edges at a known distance. So, the length capital L is known to us. 4 is a constant. B is the breadth of the beam, which we can calculate with the help of vernier calipers. And D, thickness of the beam, can be measured with the help of screw gauge. So all other factors are available, and delta by M is available from our graph. So all these values can be substituted and the Young's modulus can be calculated. Moving on to our next topic, that is I form of girders. What is girder? It's a large iron or steel beam which is used for building bridges and the framework of large buildings. You might have seen this shape in the bridges. So we have the expression for Y. Young's modulus, or you can write the expression for delta from this. How we will write delta? Delta as WL cube by 4Y BD cube. So you can see delta, that is the depression, is directly proportional to the cube of its length. So depression is directly proportional to cube of length and inversely proportional to breadth and cube of the thickness, that is D cube. You have to write delta from this equation and see how delta depends on B, D and L. Delta, which is the depression, is directly proportional to the cube of its length and it is inversely proportional to the breadth and cube of thickness. And these girders must be strong and it used in a building should not bend, isn't it? Should not bend means the depression must be small. And we know that depression is directly proportional to L cube. That means in order to get lower depression, the length of the girder must be small. Whereas depression is inversely proportional to breadth and cube of the thickness. That means breadth and thickness must be large so that the depression occurred in these girders must be small. So as the girders carry huge loads, maximum stress will be acting on the upper and lower layers of the girders. Because we know that when a force is applied or when a stress is applied, the layers away from the neutral surface undergo elongation and contraction, and it is the neutral surface which never go elongation and there is no contraction for neutral layer. So the layers near the neutral surface will not be subjected to much strain, but the maximum stress is acting at the upper as well as lower layers, so that the girders are constructed with upper and lower faces more stronger than the middle portions. That's why these girders are having the shape of I in English alphabet. So I, you can write I, when we will write I, you can see the upper and lower portion are made stronger and the middle portion is made smaller. So that the cross section of girders are having the shape of the letter I in English alphabet. And making girders in the form of I will save a lot of material. So that is an advantage of making girders in the form of I. I repeat, whenever stress is applied, compression and elongation occurs to the layers which are away from the neutral surfaces. So that portions must be stronger, whereas neutral surface, the layers near the neutral surface will not be subjected to much strain. So that we are making girders in the form of I. And lot of material can be saved by constructing girders in the form of I. Thank you.